So part 1 in question 8, actually it was a bit tough, wasn't it? I mean, it's only 2 marks, but 3 fractions is quite heavy going, isn't it, to put those together? We're looking for putting it over a common denominator, aren't we? And in this case, the common denominator, because they don't have any factors in common, has to be the product of all 3 things multiplied together. So our common denominator, and we've got to show that we're doing this, is putting it all over r minus 1, r plus 1. Can I fit these all in as... Yeah, I'm not going to fit them in. I'm going to do it now. There we go, so there's my 3 terms. Now my first term I've multiplied by r and r plus 1. So I'm going to multiply the top by r and r plus 1. Plus 1 there. My second term I multiplied by r minus 1 and r plus 1. So I'm going to multiply the top by r minus 1, r plus 1. My third term I've multiplied by r and r minus 1. So I'm going to multiply the top by r and r minus 1. There it all is. That line is pretty much essential if you are convincingly showing that we're getting that result. The bottom line is let's put it all over that common denominator of r squared minus 1, because it's a difference of 2 squares there. Now we need to tidy up the top. Just check that we've got the right things here. We've got 3r squared plus 3r. Here we've got minus, well that's r squared minus 1, isn't it? So that's minus 2r squared plus 2, because it would be minus 2 times minus 1, so that's minus minus plus. And here we've got minus r squared plus r. And the point at this point is, even if you've made a little mistake with the signs, you know that that should have been what it was supposed to be. So we're probably not even going to check it, we're just going to write it down and work our way to all of the marks. Hope nobody notices if we've missed a sign in there. That is right, isn't it? The r squareds cancel out, 3 take away 2 take away 1 is 0. 3 plus another 1 is 4, and then we've got the plus 2 there. So yes, done it. Right. Hence, find an expression in terms of n for this thing here. Look, we're starting at r equals 2. Always check to see what value you're starting at. Apart from anything else, if we started with 1, we'd end up divided by 0, and that would destroy the known universe, so we're not going to do that. But check that we are starting at 2 anyway. Check that we're going to n, check that you know exactly where you're going with that. So we are doing the sum, part 2, the sum as r goes from 2 to n of this thing that we had, 4r over r squared minus 1. Right, it's a bit dull to write all this out, but we know from this is the hence bit, we know that that's the same as the sum of 3 over r minus 1 minus 2 over r minus 1 over r plus 1. So let's start throwing some numbers at that and see what drops out. If we throw 2 into there to begin with, because that's the first value, we get 3 over 2 minus 1 minus 2 over 2 minus 1 over 2 plus 1, so that's 1 over 3. Okay. So we've got a feel for this already, haven't we? If we put the next number in there, which would be 3, we're going to have 3 over 2 minus 2 over 3 minus 1 over 4. And we've got the pattern sorted. We're okay with the pattern. This is going to be 3 over 3 minus 2 over 4 minus 1 over 5, because we can see, can't we, that the top numbers are going 3, 2, 1 each time, and the bottom numbers are going up in sequence. So 3, 4, 5 will be there. I'm into this now, so I'm going to do one more. 3 over 4 minus 2 over 5 minus 1 over 6. Okay, I've got my pattern established. I'll check that things will cancel up in a minute, but we're going to miss out all the middle terms, and let's put a few in at the end. So hang on, if we go, I'm going to put the last 3 in just to be certain that I've got enough. That's probably more than I need. But if I do n So that would be n minus 2, n minus 1, and n. So n minus 2 would start with 3 over n minus 3, minus 2 over n minus 2, minus 1 over n minus 1. And then I'm going to go plus 3 over n minus 2, minus 2 over n minus 1, minus 1 over n, and then 3 over n minus 1, minus 2 over n, minus 1 over n plus 1. Because I'd spotted, hadn't I, that they went in sequence on the bottom, so there they all are. Right, now the mark scheme, the examiner does want to see you recognising that terms will cancel out. So you have to show that terms cancel out. It's the kind of thing where you'd want to have different colours and be able to do it in different colours, but you can't do that. But we need to find some way of convincingly showing that we've got the cancelling here. So what have we got? We've got, how is the cancelling working? We've got some terms that are over 3, and we've got 3, take away 2, take away 1. So there we are, we're cancelling out there, aren't we? Because we're always going to have 3, take away 2, take away 1, and that's always 0. So they cancel out. We could even do a line that goes diagonally like that, couldn't we? And then they cancel out. And then they, well, that cancels out with those ones. Yeah, I've kind of missed out my thing there, haven't I? That looks awful now. But you've got the idea of where the cancelling is going. We've got that line cancelling out. So what are we left with? We're left with a 3, take away a 1, plus a 1.5 from the first term. And at the end, the only terms we're left with are a minus 1 over n, minus 2 over n, minus 1 over n plus 1. So we've got 3 take 1 is 2, plus 1.5 is 3.5, so 7 over 2. We're subtracting 3 over n minus 1 over n plus 1. As a general rule with these things, don't waste any energy on then turning this into a beautiful form. This then doesn't need to be put over a common denominator. It doesn't need any dressing up doing to it. Once you have got like terms collected together, leave it in that format. Did you spend quite a lot of time tidying that up? Really nicely, but that was it. I'm afraid I didn't even look at what you did after that. It may have been beautiful, but once you got that, you got all the marks, and that was it. Right. Hence, 6 marks for that though. Hence, find the value of the sum to infinity. But look, it's not the sum from 2 to infinity. It's the sum from r equals 4 to infinity. Right, of this sequence. Okay. We've got a couple of choices, haven't we? Okay, we could. The way that I did it was I thought if I did the sum of the whole thing to infinity. Oh. Look, we'll pretend I meant it. If we do the whole thing to infinity, then I'm wanting to go from r equals 4 to infinity. I could think of that as being the sum as r equals 2 to infinity. Take away those 2 extra terms that I've added. Take away the r equals 1 term and the r equals, hang on, what am I doing? Oh no, I started with 2, didn't I? So take away, oh, massive brother. Take away r equals 2 and r equals 3. That's right, isn't it? Does that make sense? That's not a particularly kind of clear diagram, but you see what I'm saying there. I'm doing the sum as if I'd done all of it, and then I'm going to take away the 2 terms I don't want, r equals 2 and r equals 3, because I'm supposed to be starting r equals 4. The whole thing to infinity, well, that term would go to 0, that term would go to 0, so the whole thing to infinity is 7 over 2. if r equals 2, then I have, if I sub 2 into that, I have 2 4s are 8 plus 2 is 10. Oh, come on. I have 10 over 2 into that would give me 2 times 3, so that's 6. And if I sub 3 into it, I get 4 3s are 12 plus 2 is 14 over 3 times 9 minus 1, 3 times 8 is 24. And I could stick that into my friendly neighbourhood calculator if I wanted to, and it would give me an answer of 5 over 4. And that's one way of doing it, and that's my first instinct was to do that. I also, when I worked this out as you were doing the exam, I did it twice, because I also thought, hang on, I've written out, beautifully written out, much of this series. I could recognise that if I was doing this forever, these terms down here are just getting smaller and smaller all the time. And everything else is going to cancel out. And these terms that get smaller and smaller are actually going to all cancel out if I'm doing it forever. They'll keep cancelling out forever. And the bit that I'm left with is going to be so small as to make no difference. So all I want is if instead of starting at 2, if I'd started at 4, what would have been the terms that I would have been left with? And if I'd started this sequence at 4, then I wouldn't have cancelled out those 3 expressions there. So actually another way of arriving at my answer is doing 3 over 3 minus 2 over 4 plus 3 over 4. And well, you can see straight away, can't you, that that is also equal to 5 over 4, because we've got 1 plus a quarter is 5 over 4. So another way of thinking about it was reimagining the previous bit that you'd done and saying, actually everything, if you did it forever, everything would cancel out, apart from the 3 that wouldn't cancel out at the start, the 3 terms. And that's what they'd be. There we go. Whichever way you do it, it was 2 marks at the end of that. That's series.